This is example 13 from the supplemental topic involving discrete random variables from your student packet. It says, suppose that 40% of all college students smoke cigarettes. If 15 are selected at random, what is the probability that 10 smoke? So notice that we don't know a position for these 10. So we don't know if it's the first 10 people out of the 15 that we select that smoke, or the first one doesn't, and then the next 10 do. We do not know the order of these 10, and that's how we know that we're going to be using one of the binomial commands. So in this case, we're looking for the probability that exactly 10 smoke. So we're going to use the binom PDF command. We have a total of 15 people that we're selecting, and the probability of success, now a success in this case is that they smoke, which is not a good thing, but the probability that we choose somebody that smokes is 0.4, and we're looking for the probability that 10 out of these 15, exactly 10 out of these 15, smoke. So if you put this in your calculator, you'll get 0.0245. The next part says, what is the probability that at most 12 people smoke? So at most means no more than 12. It means 12 or fewer. And this fits the binomial CDF command. Now the one trick with the binomial CDF command is that it only works for that number or fewer probability. So for this problem, it works perfectly. So we're going to use CDF this time, and it's going to basically take and calculate the probability that 12 smoke, or 11, or 10, or 9, or 8, or all the way down to 0. But it will do this for us, so we don't have to do each one separately. So if you put this into your calculator, you will get 0.9997. Notice that I am not rounding too much here. It's not a perfect probability. I don't want to round this up to 1. So unless you have a gazillion nines, don't round. Then it says, find the mean and the standard deviation of the number of college students who smoke. So for the mean, the formula for this is n times p, where n is the total number and p is the probability. So it makes sense that to find the mean, we would take 15 times 0.4, and we would get a probability of 6. Now it happens that we get a whole number here, but if you don't get a whole number, say I had gotten 6.43, then leave it as 6.43. Do not round that value. It's okay that an expected value is a decimal point. Just think of the scenario where they say like every household has 1.5 kids. Obviously nobody has 1.5 kids. It's not possible. But saying that there's 1.5 kids is closer information than saying that people have 2 kids per household or 1 kid per household. Okay, I digress. We also want the standard deviation. And the standard deviation, oops, lost my screen here, is the square root of NPQ, where N is the total number, P is the probability of success, and then Q is the probability of failure, which is the complement of success, so 1 minus P. So your two probabilities there, P and Q, should add up to 1. When you put this in your calculator, you'll get 1.8974.